we now have a panel that will explore some of these issues further. Louise Comfort, who is a professor at the University of Pittsburgh and a former director of a center focused on some of these issues. Katharine Hayhoe, who was at least a faculty member at Texas Tech, I think still is, but primary role right now is as chief scientist of the Nature Conservancy. And John William Nielsen-Gammon, who is the state climatologist and at Texas A&M University. Louise, I'd perhaps turn to you first to start off this panel.
Thank you. Thank you, Danny. And I'll really start. My role, I believe, is to address the social challenges to resilience. My background is public policy, and my focus has been what kinds of information do decision makers do, and what do they do when they face a situation and they don't know what to do. And this is what we see. Practicing managers who have trained for years are now facing challenges they've never seen before. And as hazards increase in frequency and intensity, the risk also increases in scale and space and time. And this creates these compound and cascading events that multiply disruption and the costs of extreme events. I'm now in California, and last year in 2020, the whole world was dealing with COVID-19, and threatened the local, state, and national health systems. But at the same time, hurricanes, wildfires, floods, and earthquakes were occurring at regional scales. And in 2020 in California, we had the unusual meteorological phenomenon of the lightning complex fires, where on one night, August 17th, 11,000 dry lightning strikes struck the very dry brushlands and forests of California and ignited massive wildfires. And if you know the Bay Area, then there are 9 counties. 8 of the 9 counties in the Bay Area had wildfires burning simultaneously, each of them draining responses from CAL FIRE, the state response agency. And this was only in California, but it also moved to the west, to Montana, to Oregon. And at the same time, there were 4 hurricanes that struck the Gulf Coast states and river flooding in the Midwestern states. So every speaker in this panel has noted that climate change exacerbates these extreme shifts in the weather systems, which cause environmental impacts and really create long-term problems for the management of these consequences, water, drought, and that leads to disruption in social and economic conditions. So to echo Amr El-Nashai's introductory comments, we're dealing with complex systems of systems, not one system, but multiple systems interacting, conflicting with one another, and that resilience really requires a systems approach. Next slide, please. So what have we learned about resilience and communities that are exposed to hazards? We do know that a systems approach to building resilience is essential, but it's not easy, and it requires multiple actors and interdisciplinary perspectives to create a collective learning process. The good news about resilience is that people can learn and do learn and are able to adapt and change once they understand. The hard part is getting them to do it together collectively. We have also learned that knowledge of past events, regrettably, rarely translates into action to reduce future risk. And so it's understanding this complexity, the interacting dimensions of space, time, and scale that challenge the communication of risk that leads to action. We have what the physicists call complex time, where risk is perceived differently by different groups of people in different locations at different degrees of urgency. And in order to respond appropriately, we need to respond to risk, we need to respond collectively. So cognition of risk depends on both the social and the technical systems to decrease uncertainty and enable timely informed action, not just by the emergency responders, but by the hospitals and the businesses and the universities and the grocery stores and the groups of people in their neighborhoods. So resilience is really a continuous learning process for interacting groups, agencies, and communities. Next slide, please. What don't we understand? Well, we know the situation is complex. We know the systems are interdependent, especially between the natural and built and organizational infrastructure. But we haven't identified exactly how they are interdependent and how the feedback loops among them work. And so we have systems that are spinning in different directions that are conflicting with one another and creating situations where floods wipe out entire towns, where wildfires, the ignition of a spark from a hammer can set off the Tubbs fire in Napa County. And the more difficult part is that we have varying rates of change in different subsystems. The energy system changes at one level. The water system, especially in the southwestern part of the United States, is really changing significantly, which accentuates the drought, which accentuates the wildfire risk, transportation changes, and economic growth. And these differing rates of change have different impacts on the population groups, as Dr. Hubbard showed us this morning, where poverty is almost always accentuated by difficult hazard events. What also we don't understand is the cumulative cost of failure to take action to reduce escalating climate change is potentially exceeding the available resources for managing hazards in many of our cities and our counties and our states. And we don't understand very well how to design policies and procedures to enable broad, diverse communities to learn and act collectively to reduce risk. Our society is too divided. There are too many differences, too much distrust, when what we need is collective response to risk. Next slide, please. So what needs to be further integrated into policies and practice? The basic science underlying hazards needs to be integrated into policies for allocating resources and estimating the time that it takes to mitigate the impact of climate change. We're running out of time, we know that, but we still haven't mobilized the action that is necessary to do that. We do have some good news then that advances in monitoring, updating, and analyzing information regarding extreme events is improving at local, regional, national, and international scales. Almost all communities in California now have GIS systems. This was not the case 10 years ago, or certainly not the case 20 years ago, but the capacity to gather, collect, and analyze information on the changing conditions that we're confronting is improving, but needs still to be integrated into policies. Also, what Dr. Bullard again mentioned very strongly this morning is the fundamental values of equity and social justice regarding the stewardship of our natural resources for communities, regions, and nations, and the planet need to be integrated into action and practice. And very importantly, mentioned by Dr. Hotez, is the very important means of countering the disinformation that reduces shared understanding of large-scale interdisciplinary ecological risk. Learning to act together is literally the only way we're going to combat these extraordinary risks of climate change. Next slide, please. And so and this is my last slide, how do we advance the science of natural hazards to protect our community? We need to use science as a mode of inquiry, as a method of discovery to build a current, valid, interdisciplinary, shared knowledge base of risk in a very dynamic world. And using this knowledge base, then develop models to explore the consequences of alternative action strategies. Excuse me. We need to be able to estimate the benefits of investment in, as well as the costs of mitigating risk. And this is the investment that Howard Kunruther was discussing. And very importantly, and this is what TAMEST is doing and what we're doing today, literally is to build collaborative teams of researchers, but include in those teams practicing managers, policymakers, and community leaders to design innovative approaches to reduce risk at each of these levels: community, region, state, and nation. And importantly, to use the advanced technologies to connect these diverse networks of actors in achieving a shared goal of sustainable resistance. Importantly, it also means we need to invest in continuing research, education, and broad public engagement to enhance the values and culture of managing risk in the public sphere. And with that, I'll turn it back to you, Danny.
Thank you, Louise. At the risk of hopefully not, but at the risk of losing some questions that are already there, I'd like to move ahead with our second member of the panel so that everybody gets their chance. And at the end of the panel, we'll have an opportunity to address questions that might have arose. But I thank you for those thoughts, Louise. Katharine, I now turn to you, and I will say we miss seeing you on campus all the time now, but certainly very pleased to have you with us today, and hopefully you are enjoying your new role as Chief Scientist with the Nature Conservancy. Katharine?
Thank you so much, Danny. Yes, I am still at Texas Tech, still teaching actually, even at Texas Tech, but I am also, as of this summer, the Chief Scientist for the Nature Conservancy, which works in over 70 countries around the world on climate, conservation, and biodiversity solutions, a lot of which have to do with what we're talking about today, natural hazards. So whenever we talk about natural hazards, and let me share my screen here, this is a good way to picture it. This is a diagram that originally comes from an Intergovernmental Panel on Climate Change report about 10 years ago. And it shows how disaster is actually a function of three things. First of all, it's a function of exposure. How many people, how much valuable infrastructure is exposed to a given disaster? If a hurricane never makes landfall, does it matter, in essence? So we know that where we live in Texas, we have a lot of people and we have a lot of infrastructure. And our cities and our infrastructure are growing much faster than other states. In fact, there was a guest essay. I like to share headlines here. This guest essay is just from a few weeks ago, just from a week and a half ago, talking about how Texas is the future of America as major corporations move here and as our cities grow. It's also about vulnerability, and a lot of that vulnerability we build ourselves. Here's an example of impervious surfaces in the city of Houston in 2001. And then fast forward to 2011, here's the impervious surfaces in 2011. And then fast forward to 2017 when Hurricane Harvey hit, and it's estimated that its floods were 20 times more likely because of urbanization and impervious surfaces. So we haven't even started to talk about climate change yet. We're just talking about the vulnerability that we build into our own systems. Then there's the fact that the American Society of Civil Engineers issues these regular report cards telling us how much our infrastructure needs investment in. 2 years ago, they estimated it would be $4.5 trillion within the next 5 years. And then just last year, they released a very state-specific report card, and this is the one for Texas. Overall, we got a C. Our aviation, bridges, and energy got a B, and I'm afraid the energy might be downgraded after that winter storm that we had. But our drinking water, our flood risk mitigation, our levees, our parks, our roads, all got Ds. And Todd Vottler, who many of us know from his work on water in Texas, he just published this op-ed in the Dallas Morning News just a couple of days ago, saying, if you think the Texas electrical grid is fragile, take a look at our water. Then there's the social vulnerabilities that Louise and many others, including Bob Bullard too, have already talked about. The fact that social vulnerabilities also create greater risk, whether it's historic racist redlining practices that leave low-income neighborhoods up to 15 degrees Fahrenheit hotter during a heat wave, more likely to flood because they're in the flood zones, poorer air quality. All of these social vulnerabilities contribute to our impacts as well, and we saw them in spades during the winter storm. Whether an event turns into a disaster is determined by exposure. It's determined by vulnerability. But then we've also got the weather and climate events in there too. We know that the state of Texas is already home to more billion-dollar weather and climate disasters than any other state in the whole country. We get more and different events. We get them all, from winter storms to hurricanes. Plus we have the infrastructure and the people who are exposed, because billion-dollar disasters are a function of two things: the disaster itself and the exposure, well, actually three, and the vulnerability. We tick all of the boxes. We know that we get floods. We know we get hurricanes. We get water shortages and droughts. We get record-breaking wildfires right here in Texas, not just in California. We get rains and floods. And we know that our assumptions about climate determine so much of our infrastructure. Our building codes, our agriculture, our energy demand, our flood zones, our water plans. All of these aspects of our planning are built on an assumption we rarely look at. And it's the assumption that we can drive down the road looking in the rearview mirror. That the climate of the past is an accurate predictor of the climate of the future. That's what our planning is based on. That's what our flood zones are based on. That's what the drought of record is based on. This works if the road is straight. And it has been largely straight. Of course, there's natural variability over year to year and even decade to get decade timescales. But over climate timescales, the road has been relatively straight. Until when? Until this last century. So we've been driving down that road, mostly staying in our own lane, not always, there's a few bumps and wiggles. We've been driving down this road, looking in the rearview mirror. But today, if you zoom in down the road there to the end, today we have hit the curve. Our wheels are already on the rumble strip. And it's not only about changes in our averages. We know that every season in Texas has been warming since the 1950s. We've got our state climatologist coming up who will tell us in more detail what's been happening to our state. But it's not only about the averages, it is also about the changes in the extremes. And because we are already vulnerable, like I showed you before, to more weather and climate disasters that are more damaging than any other state, we are arguably the most vulnerable state in the country to the way that climate change is taking our natural weather dice and loading the dice against us by sneaking in and changing one number into a 6, and then another number into a 6, and then another number into a 7, making our events more frequent or more severe, or sometimes both. Like what? We know that our heavy rainfall is getting more frequent because warmer air holds more water vapor. We know that some places, for example, in Houston, have experienced 3 500-year flood events in 3 years. We know that warmer water and warmer air intensifies our hurricanes They've got more rain associated with them. They intensify faster, they're stronger, and they can even be slower. When we look at specific events, like for example, Hurricane Harvey, we can even start to put numbers on how much worse climate change made it. And I want to actually just mention here that Geert-Jan van Oldenburg, who is the lead author of this study, just lost his life to cancer last week. He was a leader in the field of attribution science, and it's thanks to him and many others on his team that we were able to put numbers on just how much worse climate change is making our events, how much more intense the rainfall was, how much more precipitation was associated with the event, why it happened, how it was sustained and intensified by high ocean heat, and even increasingly, how much of the economic damages were enhanced by the impacts of a changing climate on an event which is very normal and very natural. Hurricanes have always arrived on the Gulf Coast, but they're getting worse as climate change loads the dice against us. We are even starting to be able to put numbers on heat waves like the North American heat wave that crossed the Western United States and Canada last summer. We're seeing that our extreme precipitation and our temperature is getting more frequent. And even counterintuitively, there are indications how as the Arctic warms faster than the rest of the world, the polar vortex is stretching, setting up meteorological conditions that increase the risks associated with the type of extreme winter events that we have had in the past and that we also had this past year. They've happened before, but as the Arctic warms, it's setting up the precursor conditions, so to speak, more frequently. The question is not, did climate change cause a given event? We've always had these events before. The question today is, did climate change make it worse? And 9 times out of 10, okay, not a scientific reference, most times we're able to say, yes, it did make it worse. So how do we reduce the risk of disaster? Where do we go from here? How can we address a global issue at the local to regional scale? We need to do so, and this is one of those measures of different types of research. We need to do so focusing on research that includes co-production of knowledge and social learning, working with stakeholders, working with people who have the lived experience, who are involved in the planning and the decision-making, the engineers, the city planners, the city managers, corporations, neighborhoods, water districts, to ask, first of all, what concerns do you already have? What are your concerns today? Are you concerned about coastal infrastructure flooding? Are you concerned about inland infrastructure flooding? Are you concerned about social justice and economic inequality? Are you concerned about aging infrastructure and costly repairs? Are you concerned about air quality impacts, health impacts, ecosystem conservation? Start with what we're concerned about, and then second, connect the dots to climate. How are these being affected or exacerbated by increases in heavy rain, longer droughts, stronger heat waves? Begin with what matters and connect the dots to how they're being affected, how the risk is changing. Then we can add in the future changes. What happens if we continue on a path that's similar to the one we've been on for the last 20 years in terms of our carbon emissions? What happens if we transition to a path that's most similar to where the world is heading to, given that we're going to Glasgow, the COP meeting coming up in 2 weeks? What does the difference between those two different futures look like? We take those global model outputs and we can feed them into what I do is high resolution climate projections for individual cities and weather stations that can be incorporated into the planning that people can use for health, for infrastructure, for water, for agriculture, for energy, for emergency planning, for almost anything you can imagine that has any relationship to temperature, precipitation, or weather or climate extremes. We can see what this means. We know that our seasons are getting warmer, summer's getting longer here in Texas. We see more hot days, more warm nights. The hottest days are getting hotter, our heat waves are getting longer. The work I've done has showed how our droughts are getting stronger and more frequent. Heavy rains are getting more frequent as well. And we can zoom in and look at what happens at the regional scale. And again, I'm not going into too much detail here because we have our state climatologist coming up next. But this is the information that we can use to inform our planning. We can look at issues like sea level rise, the difference between a lower future on the right for the city of Houston and a higher future on the right for the city of Houston. The difference is stark, and some of these impacts are already here. We already see headlines like sea level rise is costing Texas homeowners millions of dollars in property values. So it's not a case of having to move climate change up anyone's priority list. Today, we know that climate change is already here and it is already interacting with and exacerbating events that we already have. I want to just recommend an excellent book to you by Alice Hill. It just came out a couple of weeks ago that talks about adaptation and resilience planning for climate in a post-COVID world. We cannot afford to address one crisis at a time. We must address them together. And when we do, we see that we don't have to move climate change up anyone's priority list because whatever we already care about today is already being affected. And resilient planning requires incorporating climate changes. Why? Because we all need to plan for the curve in the road to ensure a safe future for all of us. It is literally up to all of us, and climate change affects every aspect of our lives. And that's why to care about it and to plan for it, we only have to be one thing, and that is a human being living on planet Earth. And oh, if we live in Texas, how much more so? Thank you.
So thank you, Katharine. And I hadn't quite realized, I recognized that you're called for dealing with all these climate crises. I didn't realize you were doing that with jobs as well and dealing with them all at the same time. So compounding it. We now turn to John William Nielsen-Gammon, who is the state climatologist. So John, turning to you.
All right, thank you very much. So I'm going to just wrap up this panel before we go to questions by highlighting a few of the results from a report that we just actually released a couple of weeks ago on trends in extreme weather in Texas. And we're looking out only a couple decades because that's really only as reliably as you can extrapolate past trends that that are at least consistent with climate models, consistent with what we expect to see happening with climate change. As Katharine mentioned, you really need to rely on the models going forward beyond that to see what the alternative futures look like. But Texans remember the past. They may remember the recent past more strongly than the distant past, but we'll see how that plays out here in some of the data I'm going to highlight from this. Next slide shows the temperatures. The upper left is the average hottest monthly temperature during the summertime in Texas. And we highlight both the averages for each summer as well as the long-term variations. The drought of 2011 shows up as a very hot spot on this plot. Overall, we haven't actually had as hot as summers consistently as we saw back in the early part of the 20th century, which I think is an example of how there are other things that we do to Texas that affects climate, like building reservoirs and expanding irrigation and using groundwater. All of those basically apply air conditioning to the climate system during the heat of the summer. But it doesn't do much to reduce humidity. And the plot on the upper right shows that the coldest temperatures we get typically during July and August have also been going up fairly rapidly. And even though you may have heard that this was a cool summer, it was not cool in terms of the relief from heat. We basically didn't get hardly any of that. The bottom chart shows the coldest temperature of the year. That's gotten a lot of attention recently after February. We've heard about many of the implications of that event. It's not the coldest it's been in Texas ever. There were a couple of years that got colder than that. But the remarkable thing about this winter was really how big a gap was between the last time it got cold. We had consistently cold temperatures occasionally over most of the 20th century, but the 21st century, this was the first time that the average coldest temperature throughout the state of Texas was below 10 degrees Fahrenheit. And Dr. Hayhoe mentioned that the weather patterns may be favoring colder conditions, extremes going forward, but apparently based on trends and climate models, those weather pattern trends are not strong enough to overcome the overall warming we're experiencing. And that warming is fastest in the Arctic, where our cold weather comes from in the winter time. So the overall trend is upward, but we still have that risk of extreme cold going forward. Even a couple degrees of warming in the next few decades isn't going to reduce the risk of extreme cold that much. Now let's turn to precipitation. And the overall trend of precipitation is increased precip in Texas historically. It's not clear whether that's going to continue because climate models basically fall half on one side of the possibilities and half on the other. Texas is on the dividing line between definitely drier in Mexico and definitely wetter in Canada and much of the northern United States. The trend in extreme rainfall is more robust and is more consistent with climate models. But unfortunately, it's less consistent geographically in the sense that extreme rainfall only happens occasionally, and therefore you can't really assess a long-term trend very well just from one particular location. And this is based on 120 years of data. Imagine trying to assess your own personal experience of extreme rainfall trends based on 20 or 30 years of data. It's just not very reliable. That's why I think that Houston is more prepared for extreme rainfall in the future than, say, Dallas is, which hasn't seen those recent extreme rainfalls, even though climate change is raising the risk for everybody at about the same rate. Next slide shows drought, which I think is one of the more complicated extreme events because it sort of depends on how you measure drought. The top graph shows an estimate of overall drought severity just based on rainfall, while the bottom one is taking into account rainfall and temperature. But you also have to worry about how climate change is affecting plant growth, how it's affecting the runoff versus infiltration. And it's really a very complicated thing. I think the most confident thing we can say about future drought is they're going to be hotter than past droughts. And as you can see, including temperature, whether that's being included accurately or not, definitely increases the magnitude of droughts as we measure them. So that's all that I have time to highlight from the report. Next slide, again, goes back to the cover of the report. And even though it's showing a mixed outlook with thunderstorms and rain and clouds, if we go to the last slide, there is actually the possibility of a rainbow at the end of all of this, as if, depending on how well we overcome our biases, take into account the science, and plan for the future effectively and implement those plans in a way that they'll actually have an impact. So thanks.
Thank you, John. We now have at least an opportunity for a few minutes of question from Kishore Mehta. With sea level rising, how do we convince developers and people that are moving closer to beaches?
I'm going to respond to that because this deals with cognition of risk. How do people actually recognize that? And this is where I think organizations like TAMEST can play a major role. It depends on the degree of knowledge that the perceiver has if he is able to accept and understand the risk that is presented to them. So it's not just biases, but it really is a basic understanding of what that risk is and what it means, and Howard's very important point about consequences. So it's communication, it's demonstration, it's showing visual images of what's going to happen to that house or that town.
Thank you. I wanted to follow up on a very important point that Katharine made, which I think is that this vulnerability and we've met the enemy and they are us. Sometimes we've caused our own problems. When you look at New Orleans, that the levee structures are leading to subsidence that is 5 or 6 times faster than sea level rise. And we often, we continue to make those mistakes that are, of course, exacerbating the problems that we face. Is there ways that we can address that more effectively?
I'll just lead off. I'd like to hear other people's opinions too. One of the greatest problems we have as humans is our tendency to psychologically distance ourselves from risks. And we do this in every aspect of our lives. We don't eat what we should and we eat what we shouldn't. We don't exercise as much as we should. You know, the latest is you're supposed to stand up every 30 minutes and run around for a couple of minutes. I promise you, I didn't even do that today. Yeah, exactly. We all need to go do that. And you know, classically, most people don't save enough for retirement. We view risks as being distant in time, the future, not now, distant in space, happening to people over there, not here, and distant in relevance. It matters to those people, but not to us. I was just talking to someone the other day who said, you know, I never thought that COVID was a big deal until somebody I knew died from it. And unfortunately, by then, you might have already been exposed. It might already be too late. And so we see this in play in spades with climate change because it seems like a future issue. Everybody agrees it's a future issue. It will affect plants and animals and people who live far away, but we just don't understand how it affects us. And so I think it's so powerful, for example, with the report that John just released, focused on Texas, showing what's already happening in Texas. It shows people that it's here, it's now, and it's relevant. And I think this is the sort of the missing piece that we don't have.
Louise, John, care to add to that?
I'll let John add first, and then I have a thought to add.
Okay, yeah, it's a challenge with making people aware of these things. It's, you know, I go back to the previous speaker talking about the important role of insurance in this, because insurance companies have to take the long view, and they're basically pooling risk over all sorts of locations. It's going to be a 100-year flood event somewhere in the next year. You just don't know where, but insurance companies have to deal with that. And then, but the challenge of acting on that with policy, the sea level rise example is a good one, because, well, it seems like obvious we ought to raise insurance rates in coastal regions so people don't build there. But what about the people who already live there, who would suddenly see their cost of living there go up by 2, 3, or even more times than that? They could sell maybe, but the equity in their houses just went away because their flood risk has been assessed super high. So we have to have some way of balancing out those impacts of taking risk into account, as well as spreading out that risk in the first place.
Well, I'd like to add with an adage from Herbert Simon, who was Pittsburgh's local guru. And his statement was, we can only create what we already understand. And if we don't understand that risk, we're not going to act. And this really places the burden on, I think, the scientists, the educators, the journalists, the media, the people who interact with them, and presenting that risk in a visual, vivid way that catches their attention. What is really remarkable, having studied emergency responders, is when you see it in action, when you see a practiced, experienced emergency management who recognizes that in the next 10 minutes, that wildfire is going to come over that hill, and he is able to mobilize his resources and stop, save that particular area. And this is what we need more of. And it's where I believe the universities can make a major change. And TAMEST in Texas is doing a really great job. Here in California, the university system in California is doing the same thing. All 10 campuses are now focusing on wildfire and building interdisciplinary teams. We're reaching out to organizations and in the community and trying to engage people in this. So we still have to learn how to do it and to put it into practice as well as into policy.
Well, thank you. And we're getting close to the end of time. And I apologize to Anadi, who had a question in there for some time, but I think I have there's probably a quicker answer to a second question that asking John as to state agencies in Texas that which ones are listening, for example? Which ones do you communicate with regularly, and which ones, again, are asking, and which ones are listening?
Well, I have a direct relationship with the Division of Emergency Management. I serve on the Texas Drought Preparedness Council and the State Hazard Mitigation Team, which involves coordination among multiple agencies. So I have a role already in that regard. I was pleased and intrigued to see that Senate Bill 3 from the last full session actually required the Public Utilities Commission, ERCOT, and the Railroad Commission to listen to what I have to say when they're formulating regulations to improve resiliency for things like the extreme rainfall event. I'm sorry, the extreme cold that we experienced in February. And I also do a lot of work with the Texas Water Development Board on various aspects of climate monitoring and planning. So those are the ones that come to mind immediately when talking about weather and climate issues with state agencies. It's still kind of difficult to actually use the C word at the agency level, but we're still going to try to improve our planning without overstepping our vocabulary constraints.
Well, thank you very much. And I believe we're scheduled to end at 2:10, and I'm afraid we'll probably have to do so. To Terrence, again, thank you to all the panelists. Thank you to Howard, John, Louise, and Katharine. Appreciate your efforts today. And Terrence, I'll turn it back to you.
Thank you so much, Danny. And thanks to our speakers. That was a wonderful panel session. Really appreciate all of you taking the time to be with us today and share your research knowledge with us.